All right, folks. So welcome back to this week's class. Well, actually, before I get into this concept or this practice problem, just two reminders. We have only two classes this week. On Tuesday, February 9th, it's a national holiday. It's Qatar National Sports Day. So there's no school on Tuesday, which means we miss a class, which is okay for our timeline. So what we're going to do this week, the second thing that I wanted to mention is we will work through this chapter today. We'll finish it on Thursday and have review. So there'll be time for some review on Thursday. Hadil asked, how much is test number one worth? It's worth a lot. It's worth 20%, but it's a pretty easy test, I must say. But it is worth a fair chunk of your marks at 20%. So this week we have class today, no class on Tuesday, no school on Tuesday, actually. You get to take a break. And then Thursday we'll finish this chapter and start our review. I can answer that, Aman. I might make, if we don't have full review time, like if we run out of time on Thursday afternoon, I think I'm going to make a tutorial video on YouTube where I can work through some practice problems as well. I'm getting so many questions. I don't know about your labs, but I can check right away. And Aman, how many questions? There are 10 multiple choice and 6 short answer questions. And I can't really say much about those right now. I'll get into the types of questions on Thursday, like specific what what you need to know, but there's 10 multiple choice and 6 short answer. It's a very straightforward and short test. Now, about your labs, I'm just going to double check because I don't want to lie to you. You are correct. There are no labs this week. Okay, let me share my screen. Your lab schedule is posted on the D2L. So this is under content labs, lab schedule, and there's no labs this week. So you guys don't have labs and you don't have class on Tuesday, which is nice. You get to relax. No definitions and no labs this week. And Aman, there will be revision in the form of your worksheets. And we'll talk a little bit more about that on Thursday. But if you guys want to practice this week, I highly recommend going through the PDF documents like the worksheets, just like I had in chemistry 1120, if you had me for 1120. But if not, the revision I would look at would be your worksheets with answers. These are some great PDF documents where you can practice. It's in D2L right now. Units 1 and Units 2. Here's Unit 2. They're all in D2L. All right, let me get back to this practice problem. Don't save. Oh, you guys probably, can you even see my screen? Yes, okay. All right, back to the practice problem. We're not in a rush, but I do want to kind of get through the next section today. So there's only one trick to this question. The trick to this question is that you need to put this heat term in the reaction, okay? The question is, does it go on the products or reactants? So guys, this is positive. It's endothermic. I want you to tell me, does it go on the products or the reactants? Yasmin is correct. It goes in the reactants. Thank you, Aman, as well. And Abdul Halim. Thank you. You're all correct. There's a question or a comment in there in the chat from Naraz, but I'll get to that after I finish this. Okay, so 38.7 kilojoules and add it over here. Okay, so the next thing you do, and guys, I'm going to kind of cheat a little bit. I'm just going to show the answer to save a little bit of time instead of me writing it out. This is definitely wink, 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 And when I say definitely, I mean definitely a test question. There are 2 steps to this test question. Let me change my color. I'm feeling green today. So there are 2 steps. On your test, you'll be given an equation like this, and you'll have to calculate, of course, the heat. So step number 1, find the moles of the chemical you are given. The only chemical we can find the moles for is the ethanol. We have the mass and molar mass of this compound. So mass divided by molar mass, you will be given the molar mass. I think Harold and a few people last day were very excited that I'm giving you the molar mass, so you'll be given this number. So mass over molar mass. The formula for this is in your data booklet. You don't have to memorize any formulas. Okay, so I get my moles. The problem is I know the moles, but it's not asking for moles, it's asking for heat. So what you do to find heat is you take your moles and you multiply it by what's called the mole ratio. Now, the mole ratio is what you're looking for over the number that you have. We have the moles of ethanol, and we're looking for the heat. So I multiply it by 38.7 over 1 moles, and I get my answer, 12.6. That's it. There's 2 steps. So step 1, find your moles. There's only going to be 1 chemical for you to find moles. You'll have mass and molar mass. And then step 2, calculate heat by multiplying it using the ratio. If any of you guys are wondering, hold up, where does that 1 come from? Where did this 1 come from? It comes from the coefficient in your chemical equation. It will typically be, a 1 or a 2 or a 3. Okay, or a 4, I don't know, but like it's not going to be a number like 55. It'll be 1, 2, or 3. This is literally review from Chemistry 1120. The only difference is we put in a heat term or a Q. All right, cool. I got chat's going crazy. Okay, so Abdul Halim, I answered your question. Aman, it is not dissolved in water, and you can tell it's not dissolved in water because there's no aqueous solutions up here, so it's not dissolved in water. Harold, I'm glad you're excited. And Aman, if it was negative, you can put the negative in the answer. It doesn't really matter for this type of question. So for this particular question, the negative won't matter. You would just say, the heat is absorbed or the heat is released. So in this case, because it's endothermic, the heat is absorbed or required. Okay, but you're more than welcome to put the negative in, no problem. So yeah, if you see a negative, you can put it in your final answer. Okay. No, like if it was exo, you could put the negative in, or you could just say that the heat was released. Like if this was exo, let me clear my writing here. Oops, sorry. If it was exothermic, the question would say how much heat is released. So you don't have to say anything because the question is telling you if the heat is required or released. So you don't need to worry about the negative. All right. I am Abdul Halim. I am the person correcting and creating your test. There's another instructor. We're going to use similar tests, but for you guys, I made the test. So it's my test, and I'll be correcting it. The other comment, and this is a touchy subject because there's not much I can say. I just follow what my boss tells me. It was earlier on from Nares. He asked, or you asked, sorry, There is a lot of people who catch the virus on campus, and it's concerning to go to the campus. I totally agree. There's not much I can do except I've booked a gigantic classroom for social distancing. We'll wear our masks, and I mean, I'm just following the rules of the college. If anything changes, I will let you know. All right, and Aman, this is one of the questions you should definitely know. All right, okay, to the next section. The next section is pretty quick. There's only 7 slides, which we'll finish today, of course, because it is a very, well, it's kind of a quick section. There's a little bit of work involved. So just let me open it up. Chemistry, 1121. I'm talking to myself as usual. All right. Now, one thing about this is, unfortunately, the way the course is working and the time is working, you've done most of this stuff in the lab already. So for today and Thursday, a lot of this information you can apply to what you've already done. Hopefully by Unit 3's lab, you'll be caught up to the course information because there is no lab this week. So this section is all about relating. This is kind of like if you were asked a calorimetry question, this is part B of that question. So just remember back to last week and your lab the other week when you were calculating heat from a calorimeter, Q. Well, there's one extra step involved. Once you find Q, you can actually find delta H, or enthalpy. So this is exactly what we did last week, but I'm going to add a step to it. Okay, so we've done all this before. I'm just going to add a little step. Okay, so there's 2 kind of topics left. We are concerned about calculating enthalpy. There's 2 ways you can do this. You can calculate enthalpy using a book where you don't have to go into the lab, you don't have to touch a chemical, you can open up a book and use textbook values. That is what's called Hess's law, which you guys unfortunately did in the lab last week before we got to it. The other way to measure enthalpy, or delta H, is in a real life situation in the lab. You can use a calorimeter. So enthalpy changes can be measured using calorimeters. So what I mean by that is, once you find Q from your calorimeter, just like we did a week ago, no differences, you can then use the moles of your chemical to find delta H. Now, you guys are expected to know how to rearrange equations, but this is the equation that is going to be more useful to you. This is the same equation rearranged. This is the equation that we'll use most of the time. Okay, especially wink, wink, when I ask you about a calorimeter question. We'll definitely do some review on calorimeters. This is one of those questions. So before we get too deep into this, let's do a little, we'll do baby steps, right? So we'll start with the easiest step. It takes 1.24 kilojoules of heat to melt 5 grams of iron. And the question is, what is the enthalpy of fusion for iron? Okay, there's 2 steps to this. If I'm asking you, now I'm not giving you a chemical equation. There's no thermochemical equation here. So we don't need any stoichiometry. Okay, if I don't give you a chemical equation, you must use our formula, this formula here. Let me not have red. What about nice baby blue? There we go. So if there's no thermochemical equation, you must use this formula. Okay, well, think about this. I have heat. The question gives me heat. Here's Q. Unfortunately, the question is giving me mass. Mass is good, but it doesn't help me solve for enthalpy, because in order to solve for enthalpy, I need moles. This is a tip I told all of my 1121 classes since the history of me teaching. If you're doing a chemistry problem and you don't know what to do, step one is to find moles. Now, more specifically, this relates to a calculation. You know, if I asked you to do something different from a calculation, don't worry about moles. But if I ask you to do a calculation, step one is typically find moles. Moles from 1121 is mass over molar mass. Now, some of you might be wondering, where did this number come from? This is the molar mass of iron, and this will, of course, as I mentioned last week, this will be given to you in the question. So you don't have to calculate molar masses. So step number one, find the moles. It's mass over molar mass. So I know that we have 0.0895 moles of iron. Okay, think about this. I know Q and I know N. Halas, I'm done. I just divide those numbers and I get my enthalpy. Sometimes people call this molar enthalpy. So typically the way I would write this, like this is a little confusing. What I would just do is go delta H is Q 1.24 kilojoules over N 0.0895 moles, and you'll get your answer, 13.8 kilojoules per mole. All right, there you go. Pretty now again, that's just part one, or that's the baby step of this. Now we're going to do a question, wink, wink, wink. That's very important. We're going to put all of this together. I'm going to calculate Q from a calorimeter, and then I'm going to find H. So if this was a question on a test, for example, part A would be to find Q, part B would be to find delta H, and it's a lot easier than it sounds. Aman, about the face shields, I'll let you know. Actually, that's a really good question. I know last semester when we had exams, there were face shields. I really hate them, but I think we might. I'll send an email to my boss today. And yes, as you said, mole is the key for chemistry. For chapters 2 and 4 specifically, it's really important to calculate moles. Okay, so let's do this one together. I think I'll do 2 of them and maybe get you guys to maybe practice one, and, ooh, and then that's it. Okay, sorry, I'm just having a look. Okay, so let me do this one. This is a good one, pretty straightforward. The molar mass of methane, and again, this would be given to you, is, I have it written here, 16.04246 grams per mole. All right, let's start this question. 1 gram of methane is burned in a calorimeter with 500 grams of water. The temperature of the water increases, oops, sorry, I didn't mean to do that. The temperature of the water increases from 20 degrees Celsius to, 46.3 degrees Celsius. Now, couple things to think about before we get started. First things first, this is not a mixture. Okay, I'm burning methane, and the heat from the methane is heating up 500 grams of water. So this is not a mixture. That's one of the first things you need to look at when you look at a calorimeter. Are the chemicals mixing, or are they staying separate? And notice I don't say anything about them mixing. Okay, if the chemicals mix, I will explicitly tell you in the question. All right, let me go back to red. It feels weird writing in blue. Let's look at this in red. And I'm going to have to write a little small, so bear with me. Step number 1, find the heat that the water absorbed. We find the heat of the surroundings. The water increases. So step number 1, I'm going to find the heat of the water. This would also be known as the surroundings. Okay, so MC delta T, my favorite formula. It's water only. It's not a mixture. So 500 grams times the heat capacity of water, 4.184 joules per gram degrees Celsius. Sorry, I'm writing a bit small. And then delta T, final minus initial. Okay, you don't have to put your units in, guys. Don't worry. I just need to see your units at the very end. Don't stress out too much about writing your units. I'm just a weirdo, and I like putting units in there. All right, so I'm not even going to look at the answer, guys. I'm going to do this with you. I'm going to pretend I'm a student. So I'm multiplying all of these numbers together. I'm using brackets on my calculator. So my Q ends up being 55,020 joules. It's positive. My calculator is telling me it's positive. Or you could say 55.020 kilojoules. Is that correct? Yes. Cool. You don't have to convert it to kilojoules, but it really helps with a number as big as this. Okay, that's step 1. Sorry, I got a really good question there. That could be a typo. Oh, no. The answer doesn't say that water is the system. I'll explain that in a second. The answer that's already there, that it's in the PowerPoint, it's not saying that the water is the system. I'll explain once I finish. Okay, that's step 1. Step 2. And guys, your steps are always the same. There's no exceptions. So I'm going to find the enthalpy of my system. Well, the enthalpy of my system is negative the enthalpy of my surroundings, which is water. So that means I get negative 55.020 kilojoules. That's the easiest mark you'll ever get. Number 3. Step number 3. And this is it. It's a 3-step problem. Now I know the enthalpy of the methane. Okay, so, sorry, I just lied. Now I know the heat of the methane. So this is for, oops, sorry. Pen is being a meanie. So I know the heat of the methane. Now the question is asking for delta H. Well, I know my formula for delta H. Delta H, I'm going to switch to orange. Delta H is Q over N. Now, the Q has to be for the methane, and the N has to be for the methane. I'm not going to calculate moles of water. I'm not asking you about the moles of water. I'm asking you about the heat of the combustion of methane, or the enthalpy of the combustion of methane. So negative, keep your negative in there, 55.020 kilojoules divided by moles. Moles is mass over molar mass. 16.042, oops, 46. Oh, sorry. And that's it. This is grams per mole. Sorry, I'm running out of room there. And that's it. Okay, use your brackets. Be very careful with your calculator, and you'll get the answer. I'm going to cheat. Negative 883. Negative 883 kilojoules per mole. All right, that's a 3-step problem. Wink, wink, wink. Exactly like you would see it, or well, not exactly, but very similar to how you would see it on a test. 3 steps. Find Q of your surroundings. Find Q of your system, and then solve for delta H with our new formula. Whew. Q surroundings is never the same as Q reaction in the sense that, sorry, guys, I'm reading one of the questions. The question was, is Q surroundings the same as Q reaction? No, the numbers are the same, but the signs are opposite. So if Q surroundings are negative, the system is positive. That's the first law of thermodynamics. They are the same number, but opposite in sign. Okay, guys, I'm going to clear my writing. Is that okay? Because I want to address another question that I had about the system and surroundings. So I'm going to clear this. I hope that's okay. Take a picture with your phone really quick if you need this. I want to address a question I had about this. The question I had was, why is this answer saying that this is water? It's not. This is your surroundings. So what this is saying is your system, the methane, would be negative the water. The water is your surroundings. Hint, hint, your water is always your surroundings, okay? I can't think of any examples where water would not be the surroundings. All right. Trying to think of how I want to do this. We got a lot of time left, but it is Sunday. I'm just trying to think if I want to do both of the, yeah, let's do both. How about I'll do one of these and then you guys do this one. Okay, cool. So let me do this one and then I'll get you guys to try the next one. And then halas, we are finished for today. And the next section won't take us too long, so we'll have some time for review. These are pretty intense problems. All right. Sorry, I'm just reading ahead. Okay. This is a good question. And this is definitely a good question to study because it's giving us the molar mass. It's telling us the heat capacity. This is a great question. So let me read it. We'll make a plan and I'll answer it. And then you guys try one and that's it. And let me check the chat before I get too deep. Yeah, Abdullah, your surroundings are basically always water or an aqueous solution. So the question was, in your test, will it be water? I can safely say in basically every situation, the surroundings will be water or an aqueous solution. So it'll be water-based. Your heat capacity, for example, C, will always be this number for a calorimeter, Okay, 10 grams of HBr, hydrobromic acid, molar mass is given, is mixed with 15 grams of sodium hydroxide. So this is a cool reaction. You guys did this in your lab a few weeks ago. You mixed HCl with NaOH. Some of you did, and some of you mixed water with NaOH, but anyways. So this is a neutralization, and I would expect a neutralization reaction to be exothermic, but let's see. So 10 grams of hydrobromic acid is mixed with 15 grams of sodium hydroxide. Both chemicals start at room temperature, or roughly room temperature, 20 degrees Celsius. When the chemicals are mixed, wink, 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 hint, 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 nudge, 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 when the chemicals are mixed, the final temperature is 46.7. What is delta H for the HBr? That's another important thing too. It's asking about HBr. It's not asking about sodium hydroxide. It's asking about the hydrobromic acid. Okay. I mean, guys, I know my game plan here. I know what I want to do. It never changes. Step 1, you're going to find Q of your surroundings. In this case, it is a mixture. You know it's a mixture because it says so. Step 2, find Q of your system. Step 3, find delta H. That is always the steps. Really, the only place that you guys are going to go wrong here is by mixing up the surroundings or the system, or by not considering that this is a mixture. All right. Let me check the chat. I got a feeling it's going to be good. And then I'll do the answer. I knew it was going to be good. So in the chat, Abdul Halim says, when it's mixed, we add the masses. And yes, sir, that is excellent. That's exactly what I wanted to hear. I'll give you a thumbs up in the chat. As Iman and some of my other students I had last semester know, I only learned how to do emojis in Zoom like 3 months ago. So anyways, okay, step number 1. Now, guys, I'm going to have to write really small. I do apologize for my tiny writing, but here we go. First things first, I want to find Q of my surroundings, which in this case is a mixture. So of course, it's MC delta T. It's always MC delta T. And as I think it was Abdul Halim said, we do need to add the masses. The minute you see mix, you add the masses. Oops. So my M would be 10 plus 15. Okay, that's grams. Then you would multiply it by my best friend, our heat capacity of water. And then you would do T final minus T initial. So T1 minus T2. Oh, that's another place you guys can mess up. Again, you like anybody who's had me before, I don't give zeros if you make a mistake. You know, I might take off half of a mark or something, but be careful when you're looking at final minus initial. So final is 46.7. Initial is 20.0. I know already this is exothermic because the surroundings are gaining energy. So, you know, I can feel that this is exothermic, but let's prove it. Okay, that was step 1. Step 2, easiest mark ever. What is your system? The energy, the system in this case is a chemical reaction. Well, it's negative Q of the surroundings. So it would be, oh, sorry, I didn't even answer. Whoops. I didn't even get the answer. I got ahead of myself. I didn't even calculate Q. Silly me. So I don't know why I don't just look at the answer, but I'm doing it by myself as usual. Correct me if I'm wrong, but guys, when I get this answer, I get 2793 joules, or 2.793 kilojoules. Okay, step 2, energy of your system. It's the negative energy of your surroundings, so it will be negative 2.793. That's an easy mark. Okay, even if you get question number 1 wrong, but you show me the step in question 2, I'll give you a mark, right? You just need to do all your steps. And then step 3, what is my enthalpy? Well, it's Q over N. So it would be negative 2.793 kilojoules. And this can be confusing because a lot of students don't know which moles to use. You're obviously given 2 chemicals, right? You're given HBr and you're given NaOH. So what moles do I use? Well, guys, the question is asking for HBr. So I want to find my moles of HBr. So now, other important thing. I only care about the enthalpy of my system. My system is my reaction I'm looking for, HBr. Do not combine your masses. Oh, let me pick a different color. And this is always true, guys, always true. Do not combine, or I should say add, M for any delta H calculations. We're only adding M masses because we're looking at the whole surroundings. The surroundings are a mixture of two chemicals. The system is not the mixture, it's the reaction. And then we're only looking for HBr. So I would take 10 grams and divide it by 80.912 grams per mole and get my answer. I'm going to cheat, 22.5 kilojoules, and it is negative 22.5 kilojoules. Exothermic reaction. I know it's exothermic for two reasons. The temperature is going up for the surroundings, and delta H is negative. And when delta H is negative, we got ourselves an exothermic system. So I've got some questions and maybe an answer. Since we mix two things together, aren't we supposed to have 2C? And then Abdullah says C is a constant. And then Abdullah asks about the surroundings. We might go a minute or two over today, guys, but that's okay. So to answer everybody's questions, Iman, you never use 2C, two heat capacities. And I've said this in other classes, we always make what's called an assumption. Okay, an assumption that a mixture of two aqueous solutions would share the heat capacity, or sorry, would have the heat capacity similar to water. And I've mentioned this in other classes. It's like when you are doing a physics example and you ignore the wind or the friction. We make assumptions in science, especially in first year science. So it's 4.184. We do not need two C's, two heat capacities, because we always assume that aqueous solutions have the same heat capacity as water. You guys did this in your lab. Oh no, I'm getting so many questions. I love it, but I'm going to run out of time. How do I know HBr is the surrounding? HBr is not the surrounding. HBr is the system. And I know it's the system because it's what the question is asking for. The other question, the surrounding is the mixture. The system is the HBr. I have a private message from a student. It says in the question before, why didn't we add the masses? Because it was not a mixture. Okay, you only add masses if it's a mixture. This is not a mixture. This is a mixture. It says explicitly in the question that the chemicals are mixed. Whew, okay, we don't have much time, but I'm going to use my time because I really want you guys to practice one of these before I go. So guys, just take 3 minutes to see if you can do this question. It's exactly the same as the last question, just has different numbers. I will give you 3 minutes to try this. And then I will whoa, that's a weird looking face, but I'm going to stick with it. I will very quickly go through the answer, and that's it for today. So 3 minutes, and I'll be right back. If you don't know what to do, refer to the last question, the previous question, sorry. Okay, so 3 minutes, I'll be right back. So this is the same as the last question, same concept. I'm dealing with a mixture. Sorry, I'm dealing with a mixture. When you see the word mixed, you add your masses. And my system is the Ki, the potassium iodide. Okay, again, kind of going back to the other question, I'm going to assume C is the same as water. I'm not going to worry about calculating or a new C or using two C's. So the chemicals are mixed. My system is Ki, and my heat capacity is the same as water. Oops. So pen. Step number 1, same as always. Q of my surroundings. Because it's a mixture, I add my mass. Actually, here, to save time. Yeah, let's do this. To save time, I'll do it this way. I'll just put the answer up. Okay, so step number 1. Q is mc delta T. The mass is the combination or sum of the total masses. Okay, why am I doing the total mass? Because Q is a mixture. So my surroundings are a mixture of two chemicals. If you can't separate the chemicals, you have to add the masses together. Okay, it's not like dropping a piece of metal in a solution of water or burning methane around a solution of water. This is a mixture, so that we get the total mass, heat capacity, and delta T. Now, one thing that's really interesting here, guys, is it's final minus initial. When you do that calculation, you get a negative value. That's okay. It's meant to be negative. The math will always tell you if it's positive or negative. Trust your math, okay? Now I want to find Q of my system. That's my Ki. So Q of the system is negative Q for my surroundings. Basically, I switch the signs and it becomes positive. That's okay. That's step 2. Whoops, I'm going to go back to red. Step 3 is to calculate delta H. Now, I do mine a little differently than this example. What I like to do is rearrange my equation like this. So I just go Q over N. So it would be, oops, sorry, slippery fingers, positive 8.0 kilojoules over my mass over my molar mass. Sorry, I'm running out of room there. Okay, and that's where you get your answer. 26 kilojoules per mole. Sorry for writing so small, but the way that these slides are laid out, the person rearranges the equation after. I'm more of a fan of rearranging my equation first. So how do you guys feel about that? That's it for me today. I did go 5 minutes longer, but it's I had a lot of questions, but that's good. Questions are good.
Answer is 26 or 265.
Oh, sorry, 265. You're correct. My bad. My bad. My bad. It's thank you for writing that and reporting that. 265 kilojoules per mole. I'm running out of room. I feel so silly. Positive 265 kilojoules. Thank you for that. Yes, Aaron, I will upload this right now, right after class. So you can check this out. It takes YouTube maybe 20 or 30 minutes to render the video, but it will be up. You know, if you take a break, maybe have some food, it will be up by 6 o'clock. Okay, guys, that's it for me today. I'm going to stop right now because it is 5:26. Have a fantastic night and evening. Any questions this week, send me an email. If you guys want to come to my office hours, have a chat with me, send me an email or come to the office hours. I'll see you guys soon, and we will have class on Thursday. All right, goodbye, everybody.
Thank you, Mr. Mark.
Thank you so much.
Bye, sir. Thank you.
Bye. Thank you. Take care. Stay safe. Have a great day.